Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 7, Lesson 3, Multiplying Polynomials and the Special Cases. After this lesson, you'll be able to recognize patterns to multiply binomials. In the Explore and Reason, we have this table, given these values for x and the values for y, and different expressions. So we have the difference of x and y multiplied by the sum of x and y. Then we have x squared, we have y squared, and then we have x squared minus y squared, or this is the difference of the two squared. So let's evaluate the expressions. If I subtract these, I get 3 times, and I add them together, I get 11, so my product is going to be 33. And then if I do 6 and 2, so subtract the difference, I get 4. I add them together, I get 8. My product is going to be 32. And then I subtract them again, and I get negative 6 times 12, and that equals negative 72. So we've evaluated that third column. Let's just square all the x values. We'll have 49, we'll have 36, and we'll have positive 9. We'll square the y values. We get 16, we get 4, and we get 81. And then if we do this last column where we take the squares and we subtract them, so all we're doing is this column, x squared minus the y squared column, and we get 33, we get 32, and we get, if I do 9 minus 81, negative 72. So what do we notice? Well, we notice that these two columns are the same. So this expression, this difference of two squares, is the same or equivalent to that expression. So what patterns are there that can help us to more efficiently, more quickly multiply polynomials? So we have this expression a plus b squared. Okay, so a and b are just any values. I'm going to square the sum of them. So if we were to expand it out, what does that mean? If I square something, I multiply it by itself, and then we can use the distributive property. So I'm going to multiply the first term, a, by each term in the second. So that's what we have here. And then I'm going to take the second term, the b, and I'm going to distribute it and multiply it by each term. And that's what I get there. And then if we simplify, a squared, or a times a is a squared, a times b is ab, b times a is ba, or ab, and b times b is b squared. I can combine these two because these are like terms. They're both ab's. They're going to give me the same product, so then I have two ab's. And we have this beautiful pattern here. You'll want to remember this. If you have the sum of two numbers squared, it's going to be a squared plus 2ab plus b squared, twice the product of the two terms. You can see the area model as well. If we did our area model, each expression is a plus b, and we saw the area model, and then we combined our diagonal terms, our ab terms, we would get the same expression. A squared plus 2ab plus b squared. What about if we are subtracting two terms and then squaring it? Okay, we have this binomial, but we're looking for the difference, and then we square it. So we can think of it as adding a negative, right? Subtracting 3 is the same as adding negative 3. Then we can apply this pattern, a squared plus 2ab plus b squared. So I take the first term, which is 5x, and I square it. So the whole thing 5x is squared. Then I take the second term, which is negative 3, and I square it. And then I multiply the two terms. Okay, so I'm going to multiply those two terms. 5x times negative 3 is going to be, well, negative 15x, right? So that's what we're doing here, is we're multiplying those two terms, and then we double it, because that follows our pattern. 2ab. And so that can help you more efficiently multiply these binomials. Just remember, if you are subtracting, it really is just adding a negative. So then our middle term is going to be minus 2ab instead. So then if you have a difference that you're squaring, it would be a squared minus 2ab plus b squared. Okay, that negative sign is the only difference. Make sure that you are squaring the whole term of a. Okay, you're squaring 5 and you're squaring x. So that's a common mistake. So make sure you're squaring the whole term. It's helpful to put it in parentheses. So part C, how can we use the square of a binomial to find 29 squared? Well, we can turn it into two terms. We can say 29 is the same as 30 minus 1, right? And we can do the math easily with 30 and 1. We can square 30, and it's 900. We can square negative 1, it's positive 1. And then we can multiply 30 times negative 1 and double it and get negative 60. So this can be helpful to doing very fast or efficient math, if you remember this pattern. Let's practice. Find each product. So again, we're going to look for that pattern, a squared plus 2ab plus b squared, or if it's negative, we're just subtracting 2ab plus b squared. Okay, so which pattern are we doing? Well, we're subtracting 4, which means we're adding a negative 4. So we're going to apply the second pattern where it's minus 2ab. So let's do that. Take the first term, 3x, put it in parentheses, and square it. I like to move to the third one, the third term in my pattern. So I'm going to take negative 4, and I'm going to square it. That's my b squared. And now I do the product. What's 3x times negative 4? So I'm going to, 3x times negative 4 is negative 12. I'm not going to show you that. It would be 2 times negative 12x. So 3 squared is 9x squared. 2 times negative 12 is negative 24x. And negative 4 squared is positive 16. So there's our answer. Okay, for part B, we need to turn 71 into two terms. We need to decompose it, break it down. Well, it is the same as 70 plus 1, is it not? And so then we can square that. And we're going to do the same thing. So we're going to take our first term, 70, and we're going to square that. And then we're going to take our second term, our b term, and square it. And to get the middle term, we multiply. So 70 times 1 is 70, and that means we double it. 70 squared is 4,900. 2 times 70 is a positive 140, and 1 squared is 1, and we can add those together. So if we add them all together, we get 5,041. Example 2, what is the product if I add two terms together and then I'm subtracting them? So think back to our explore and reason. This is what we were doing. So if we just apply the distributive property like we did in the beginning in our warm-up, we see that we get this pattern, the first term squared minus the second term squared. The middle terms will cancel each other out because one is negative and one is positive, so they will cancel each other out. This is called the difference of two squares. Think about the name, it makes sense. We're taking the difference of two things that are squared. So if you can recognize that you have a binomial that is subtracting two terms that are perfect squares, then you know when you break it down, you get this pattern, the sum of the terms times the difference of the terms. So let's take a look at an example. We have here 5x plus 7, there's a sum of two terms, and we have the difference of those same two terms. So then we know that it's really just going to be the first term squared minus the second term squared. If we expand it all, you'll see that those middle terms will cancel each other out. So if we do 5x squared, or 5x times 5x, we get 25x squared. If we do 7 times negative 7, we would get negative 49, right? Now let's take a look. These are perfect squares. I can take the square root of 25. I can take the square root of x squared. That's a perfect square. 49 is a perfect square. Okay, and I'm just going to prove it to you. I'm going to distribute it all really quick. So I've got 25x squared minus 35x. Then I'm going to have a positive 35x, if I did it here, and then negative 49. And then again, those will cancel. So this is a difference of two squares. How can we use the difference of two squares to find the product of 43 and 37? So again, we're going to think about decomposing these numbers into two perfect squares and do the sum and the difference. Okay, So 43 and 37, they're both 3 units away from 40. So we're going to play with that. 43 is 3 more than 40, and 37 is 3 less than 40. We need that. We need one to be a sum. We need one to be a difference in order to follow this pattern for the difference of two squares. So that means I can take the first term and square it, and then take the second term and square it and subtract those two perfect squares. So if I did 1600 minus 9, I would get 1591. If ever there's a time where you don't have a pencil and paper and you don't have a calculator, you could probably do this in your head. Try it. Number 2, find each product. So again, you have to be able to recognize these patterns. That would be the first thing you do. If ever you're multiplying binomials or any polynomials, look to see first if there's any of these special cases patterns. And then you can do it using an area model or distributing. So first, let's check. Does this follow any patterns? Well, I have a sum and I have a difference. I have A plus B times A minus B. I know that pattern. This is my difference of two squares pattern. So then I just take my first term and square it, 2x squared, and I take my second term and square it, and then I do the difference of those two squares. Let's simplify it a little bit more. What's 2x squared? 4x squared. What is 4 squared? 16. So this is how you would see it. Recognize that 4 is a perfect square. X squared is a perfect square. 16 is a perfect square. I have the difference of two perfect squares. Okay, for part B, we're going to need to break these down. So do you recognize that these are close to 50? They're both 6 away from 50. So this is 50 plus 6, and this is 50 minus 6. Are we following this pattern? Yes, we have a sum of two terms, and we have a difference of those same two terms. So this follows our pattern of the difference of two squares. I'm going to take my first term, my A term, and square it, and subtract my second term squared. 50 squared is 2500. 6 squared is 36. And I subtract those two, and I get 2,464. Example 3, now we're going to apply the square of a binomial. The square of a binomial, that means if I take something, two terms, and I square it. Okay, so remember that's our first pattern too. What's the pattern? It's going to be a squared plus 2ab plus b squared. So that's the pattern we're going to get. So we have this picture, and it's pixelated, and we see there's a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what is the area of the image itself? Okay, so just the border, just the red part. We see the whole image. We can figure out the whole image, and then we could subtract the area of just the picture, because you can see here we have the length and the width of just the picture. That's the picture. And then we could figure out the area of the border, because that's what's left over. So what's the total area of the whole picture? Well, the length and width is x plus 4, so we're going to do x plus 4 squared. We're going to subtract out the area of the picture, which is x squared, to get the total area, which they told us was 176. So now let's simplify. We need to do our sum of our binomial squared. So remember, it's the first term squared plus 2ab plus b squared. So what's the first term? X. X squared is x squared. The last term, 4 squared, is 16. And then multiply them together. 4 times x is 4x, and double it, we get 8x. Okay, and then we subtract x squared. Well, we can see that if we have x squared minus x squared, those will cancel out. We're left with 8x plus 16 equals 176. Can we solve for x? Yes, we can. We can subtract 16 from both sides and then divide by the coefficient on both sides, and we get x equals 20. What does that mean? It means the length of the picture is 20, or the size of the picture of the image is 20 pixels, and it's square. So since it is square, the total area would be 20 by 20, or 400 square pixels. So make sure you read the question carefully to answer the correct problem. Look at the diagram carefully, but Again, this was easy if we recognize this pattern, if we recognize a squared plus 2ab plus b squared. Try it number 3. What is the area of the square image if the area of the border is 704 square pixels and the border is 4 pixels wide? So instead of this width of the border being 2 pixels, that's what it said originally, it's going to be 4 pixels. So I'm going to have 4 pixels extra, or width, of the red border on each side. So this would be x plus 4 over here, plus 4 more over here. That means the total length would be x plus 8. So my whole image is x plus 8 squared because it's a square. The image is still x squared, but now the area of the border is 704. And we're going to do the same thing. Okay, we have our binomial squared, so we're going to do our pattern. A squared plus 2ab, 8 times x times 2 is 16x, plus b squared is 64. And sorry, this needs to be subtracting. We're subtracting the area of the picture. So minus x squared equals 704. The x squareds will cancel. So now I have 16x plus 64 equals 704. Subtract 64 from both sides. 16x is going to equal 640. Divide both by 16. X is going to equal 40. So the length of the image is 40 and the width is 40, so the total area is going to be 1600 square pixels. We made it to the concept summary for multiplying special cases. It will always help to have this pattern recognized, a squared plus 2ab plus b squared, and to recognize the difference of two squares, where we add the terms together and subtract the terms together. And that product is going to be the difference of those two perfect squares. So memorize these patterns so you can recognize them and save yourself some time. If you have any questions, put them in the comments. Make sure to like and subscribe and come back for lesson 4.